Hello, welcome to this lecture video. So today we will be discussing mortality frequency measures. So for mortality rate, this is a measure of the frequency of occurrence of the death in a defined population during a specified interval. So morbidity and mortality measures are often the same mathematically. So it's just a matter of what you choose to measure. So it can either be illness or death. So we have here the formula for the mortality. So it is deaths occurring during a given time period divided by the size of population among which the deaths occurred multiplied by 10 raised to n. And this is the list of the frequently used measures of mortality. So we actually have crude death rate, cause specific death rate, proportionate mortality, death to case ratio, neonatal mortality rate, post-neonatal mortality rate, infant mortality rate, and maternal mortality rate. So what is the difference between these measures? So as you can see here, you are provided with what are the expected values for the numerator and denominator and our 10 raised to n. So we actually have the similar formulas for all of these measures except that the source of the values that we are going to divide. So for example, for crude death rate, what we need is the total number of deaths during a given time interval, and the denominator is the mid-interval population. For cause-specific death rate, this is the number of death assigned to a specific cause during a given time interval, and the denominator is still the mid-interval population. So as you observe here, there is also a need to multiply it by 10 raised to n. So it depends on you later if you're going to multiply it by 1,000 or by 100,000, as long as you are going to indicate that that is per, for example, 1,000 cases or per 1,000, 100,000 cases. So for proportionate mortality, what you need is the number of deaths assigned to a specific cause during a given interval over the total number of deaths from all causes during the same time interval. For the death to case rate, this is the number of deaths assigned to a specific cause during a given interval over the number of new cases of same diseases reported during the same interval. So neonatal mortality rate, so it has something to do with the age or the number of days of the children. So it's the number of death among children less than 28 days of age during the given interval. While for the post-neonatal mortality, so the number of deaths among children from 28 to 364 days of age during the time interval. For infant, if the children is less than 1 year old of age during the given time interval, while for maternal mortality, it's the number of deaths assigned to pregnancy-related causes during a given time interval. So in our next slide here, we have the examples, for instance, of crude mortality rate. So how can we compute the crude mortality rate? So given this example, so we have a total of 2,419,921 death, and the estimated population is 290,809,777. So for crude mortality, what you need to do is to determine the total or to have the data of the total number of deaths and also the population, total number of population. So if you have the data for the death and for the population, so you just need to divide that and multiply it by 100,000, and it means that that is the number of deaths per 100,000 population. So just to illustrate this, so let's open Paint. So in our paint, what we need to divide. So we have the total deaths, and total population. And this is equal to, so in our given, we have the value 2,419,921 over 290,809,777. So using our calculator, so if we compute for this, 2,419,921 over 290,809,777. So we are going to obtain this value. So the reason why we need to multiply this to 100,000 because it's difficult to get a picture of a 0.0083. So instead of dealing with that decimal, so we are going to multiply it by 100,000. And the answer is 832.13. So let us place that here. So 832.13 or 4.1 deaths per 100,000 population. So this is how to compute for the total, the crude death rate. So how about for our next example here? So we have an example for cause-specific mortality. So on the same year, so we have the same data. So it's a data from United States. It's 200 in 2003, I mean. So for cause-specific mortality rate, so we have to know what is the cost. And in the next example, so the cost is unintentional injuries or it is due to accident. So if we know the cost, then we can also compute for cost-specific mortality rate. But we're not going to include the total death anymore. So what we need to do is to consider only the number of cases. So for example, in this data, so we have 108 1,256 death attributed to accidents. And so if we will consider this, so what we need to compute is, so let's go back to our problem. So the denominator is the size of the population and 108,256 is the numerator. So using the population as mentioned, so we have 290,809,707. So we will still consider the same number of population. So for cause-specific mortality, so we know the cause. So we will just replace this with, so we will replace this with death due to accident. Okay, so, and then we will also replace the value here. So instead of using 2 million, so this will be replaced with the value 108. It's 108,256. So let us calculate this value. So it's 108,256 divided by 290,800. Oops, let's repeat that. 108,256 over 290,809,777. And click OK. So it is 3.72. By multiplying this again, so let's multiply this by 100,000. So you're going to obtain a value of 37.2. So this is 37.2 per 100,000 population. So as long as you have the data for the population, so in 2003, so this is the case in 2003, and you know the number of death also due to cause, for example, in this given, it is due to accident, you can compute for the value. So let's go back to our slide. But if you are going to use the total population and the total number of deaths, regardless of the cause, that's the crude mortality rate. But if you know the cause, then it is the cause-specific mortality rate. So how about for age-specific mortality rate? So as also used in the term itself, it has something to do with age, which means if you want to know the specific mortality rate of age 25 to 44 years old, then you can also compute for age-specific mortality rate. So in the given example, you must know the age of the individuals. So here we have a number that corresponds to 25 to 44 years old. So the denominator, so what will be the denominator? The denominator is the number of person in that age group in the population. So what will be the numerator? It is the number of death in the age group. So for age-specific mortality rate, we will not use the denominator just like the denominator that we use for crude and cause-specific mortality. So the population only is the population of the number of death in that age group. So in the given example, we have 130,761 deaths among persons with age 25 to 44 years old. Okay, so we have what we call as for age-specific mortality, infant mortality rate. That is when we know that the individual or the children involved is less than 1 year of age reported. So we have the next one, neonatal mortality. So this is already mentioned. This is when it's it covers birth up to but not including the 28 days. So our numerator rather of the neonatal mortality rate therefore is the number of death among children under 28 days. For pause, it is from 28 days of age up to but not including 1 year of age. So for maternal, So the numerator is the number of deaths during the given time period among women while pregnant or within 42 days of termination of pregnancy. So we will just divide this again. For sex specific, if you want to just consider, for example, the case of the male or the case of the female, but you have also to limit your denominator to the age for the particular sex. So if you want to compute for the male, so you will also consider the denominator as the population of the male. For raised, so you can also consider a raised or combination of specific mortality rates. So this is the example of some computation. So we have here an intentional injury is specific mortality rate for the entire population. So the number of unintentional injury deaths in the entire population can be seen in the table here. So this is the unintentional injury. The total is 106,742. And then estimated mid-year population. So what is our mid-year population? It's 2,443,300. So let us go back. Okay. So here, the estimated population, so this is the estimated population. The total is 288,357. So you will just divide 106,742 all over 288,357. So we can also go over with all-cause mortality rate for 25 to 34 years old. So by considering only the number of deaths from all causes among 25 to 34 years old. And since this is age specific, so we mentioned that you have to consider only the estimated population of age 25 to 34 years old. So you will not consider the whole population, just like when we computed for unintentional injury specific mortality rate. So similar to this. So how about if we're going to consider all-cause mortality among males? So we have the word here, males, so which means we will only consider estimated mid-year population of males. And then for letter D example, so this is an intentional injury specific mortality among 25 to 34 years old. So you have also to look at the table again to determine for the number of unintentional injury deaths among 25 to 34. And the denominator is the estimated mid-year population of 25 to 34 years old. So we have in our table the age group. So we have 25 to 34, 35 to 44, 45 to 54, 55 to 64, and others. So for unintentional injuries for males, for example, so if you will compute for that, then you have to consider 1,713 if it is 5 to 14 years old. Or if it is 45 to 54, then you have to look at the table for the value of this. So it's 10,462. So the estimated population by 1,000 multiplied by 1,000 is provided. So we have here 19,676 and 21,013. So it depends on what you need to compute, and it also depends on the case. So for example, if you want to consider sex is specific or age is specific or cost is specific, so it depends what will be the numerator and the denominator.